Hello, it's Sandalam. This is Sandalam, and now let us discuss about some introduction to data structure and algorithm. So, what's data structure? What's data algorithm? What's the purpose of using data structure? And what is the purpose of using algorithm? We will see on this videos. So, before proceeding to the data structure and algorithm, let's see about what about the program, because a data structure and algorithm are the components of the program. So what's a program? A program is a set of instruction which is written in order to solve a given problem. So to solve a given problem, we need to write some programs. For instance, to perform arithmetic operation like addition, subtraction, multiplication, like that. Performing such tasks, such problems in our calculator or in our mobile phone or laptop. Every electronic device want to perform this task needs a program which is written inside the equipment. So there is some program written in our laptop or something we are using. So the solution we are performing or the problem we want to solve, that one consists of two things. The first one, the way to organize the data, and the second one, the sequence of steps to solve the problem. So the way data organized in a computer memory is said to be data structure, and the sequence of computational steps to solve a problem is an algorithm. Therefore, we can say a program is data structure plus algorithm. Data structure plus algorithm is a program, we can say like that. So data structure are used to model world or parts of the world. We can use data structure to model the problem. We want to solve some problem, then we can model by data structure. The value held by the data structure represent some specific characteristics of that world. The characteristic being modeled restrict the possible value held by a data structure and the operation to be performed on the data structure. And the second slide, the first step to solve a problem. So we are going to solve a problem. So to solve the problem, we need programs. That program contain algorithm and data structure. So the first step to solve that problem, obtain abstraction view. We need to have abstract view or model to solve that problem. We need to abstraction. So we have to have an abstraction. What is abstraction? That is a process of classification as classifying characteristics as relevant and non-irrelevant for a particular purpose and ignoring the irrelevant one. No need to write the irrelevant one, but our abstraction may have uh, relevant characteristics. So for instance, we need to model student of Verity University, for instance, Verity University. So character name, we need car name. Car name means the data type for name, ID, department, and the age, year. The age of the student, the year they join to the university or the campus, the department, ID of the student, name of the student, and the detail for the program we are writing. So this is our abstraction and non-relevant height weight. It's not mandatory to write on our program. So the relevant one, the mandatory one are name, ID, department, age, year, like something like this are relevant one. Using this model above, using this model, a program try to define the property of the problem. We are trying to define the property. We want spend some steps to solve this problem. So the data which are affected and the operations are involved in the problem. An entity with the property of just decide is called abstract data type. What's abstract data type? ADT specify what data stored. Our abstract data type can identify or specify what data is stored, and operation can be done on the data. This stored data also used to operate the data on the computer. However, it does not specify how to store or how to implement the operation. Does not specify. It's also independent of any programming. It's not independent with any. It's not dependent with any programming language. We can use any machine language or something like that. So it's independent of programming language. So ADT employee of an organization. For instance, if we want to solve or organize one program or one task on the organization, the employee of an organization. So this ADT store an employee with their irrelevant attributes. So the irrelevant attribute one should be included on this name, ID, sex, age, salary, department, something like that will be included on our program. So when it comes to data structure, what's data structure? In contrast, a data structure is a language contract that the programmer has defined in order to implement an abstract data type. To implement the abstract data type, we have seen like name, ID, something, department, like that. The programmer has defined these data structures. So what's data structure? We have seen previously the way how organize data in a computer memory. So how to organize this data, name, ID, this one, how to store this one is a data structure, nothing. Attribute of each variable. For instance, we want to record student data like name, department, ID number, age, mark, something like that, maybe record on this. So attribute is textual label, location in memory, visibility, the scope of statement of the program, type, set of the values that can be stored, set of the operations that can be performed, size, the amount of storage required to represent the variable, lifetime, the time interval during the execution of the program will the variable. This is included on the data structure. When it comes to data, algorithm is an concise specification of operation for solving a problem. To solve a given problem, or if one to solve, or if one writes some program about the student detail, we need a concise specification of an operation or steps. Algorithm will define computational procedure that takes some value or set of value as an input and produce some value or a set of value as an output. It takes some input from the user or keyboard and then it produces the output. To produce the output, some algorithms proceed on this step. So the algorithm is a step-by-step process. An algorithm is a specification of a behavioral process. It consists of finite set of instruction. Finite set of instruction consists in algorithm that govern behavior step by step. It's a part of what constitutes a data structure model, the static parts of the world. They are unchanging while the world is changing. But when we come to the algorithm, it's a dynamic one. In order to model the dynamic parts of the world, we need to work with algorithm. So Algorithm are the dynamic parts of the program. Word model, an algorithm transform data structure from one state to another state. That's nothing but algorithm. So what's the purpose of algorithm in a program? So what's the purpose? We are using algorithm, we are talking about algorithm, we are learning about algorithm. So what is the purpose? So take value as an input. As we have seen here, it is input algorithm then output. When come to here, it takes value as an input. Firstly, we take input as a value from the keyboard. The example in C++, the input command, this one, like C program scanf. In C++, we use cin age. We want to input the age of the student or something. Change the value held by the data structure. We can change. We have seen it's dynamic parts of the program, so we can change. We have it's a receive age, then age is equal to age plus 1. We can change the organization of the data structure. Example, sort student by name. We want sort by the student name, or we want sort by ID or something. So it changes the organization of the data structure. Produce output. Example, display students information. The quality of data structure is related to its ability to successfully model the characteristics of the world or the problem. Similarly, the quality of algorithm is related to its ability to successfully simulate the change in the world. That's the quality of an algorithm related to its ability to successfully simulate the change in the world. However, the quality of the data structure and algorithm determined by their ability to work together well. Generally speaking, correct data structure leads to simple and efficient algorithms. If we have our data structure correctly, it's simple to get efficient algorithms, and correct algorithm leads to correct, accurate, and efficient data structure. If one is correct, it leads to efficient data structure. If you have efficient data structure, it leads to efficient uh, algorithm. This is little introduction on data structure and algorithm. Uh, Thank you for watching this video. Thank you so much.